Всім привіт! Давайте будемо починати. Вибачайте за цю затримку. And I will switch to English now because this conference is international, so I think it will be more appropriate. But during the breaks, please feel free to talk in a language of your choice. So let's begin. My name is Alina. I work at Oracle Labs on GraalVM, and today we'll talk with you about what is GraalVM, where you can use it, what is the current state of the project, and where is the project heading next. And tomorrow I have one more session, and we will dive deeper into performance optimizations with GraalVM. I think it's tomorrow around 1. So if you're interested in performance optimizations, please join that session too. Yeah, let's begin. So as an introduction to GraalVM, I really like this tweet because it kind of settles the level of expectations. So it basically says that Java C is one Java compiler written in Java, and GraalVM is another Java compiler written in Java. And you can use one Java compiler written in Java to compile another Java compiler written in Java, and isn't that mind-blowing? So I really like this quote, and I don't know how about you, but for me, it reminds me a bit of this, Inception movie with Leonardo DiCaprio, with the recursion levels all over the place. Moving on to more serious things, so GraalVM itself is a universal virtual machine, and the mission we have for this project is two things. First of all, we want to make programs run faster, and also we want to make developers more productive. And there are a couple of ways how we see that happening, and that is also our goals. So the first one is to provide high performance for abstractions of any language. And why we are talking about this? Because sometimes abstractions can be considered as a trade-off with performance, meaning that if you want to write good object-oriented code following best practices and with high level of abstraction, some people think that you would need to give up performance. And on the contrary, if you want to optimize for high performance, that would mean that you would need to apply different code writing techniques. While we want to make it not a choice, but a default option that no matter what language you choose, and even if you write good object-oriented code, you still get high performance. So that's one of our goals. The other one is to provide this low footprint and fast startup mode for Java applications. So the way we achieve this is by compiling Java applications ahead of time into native binaries that start really fast and don't consume that much memory because they are standalone, meaning that they no longer require a JVM to run. That's one of our goals. The other one is convenient language interop. So just as with performance, we think that is something that we can take care of for you so that you can write good code and also focus on your business logic and on your business goals instead of performance tuning or interop dealing with it manually. And the last one, since GraalVM is highly embeddable, you can embed it in different applications, embed it in different platforms, and get access to the languages and tools that GraalVM offers for you. So going into a bit more details, here is the chart that overviews, in general, capabilities of GraalVM. So on top here are the languages that GraalVM supports, and below are the platforms where you can use GraalVM. And you can think of it as of GraalVM sitting in the middle and providing interop optimizations and tooling for the whole thing. So you can mix and match those, and GraalVM will take care of the rest for you. So let's go quickly through this chart. First of all, you see on the left Java and JVM languages, meaning Scala, Kotlin, Groovy, whatever. So we support your unmodified default Java applications. So if you want to run your application on GraalVM, there isn't any compatibility efforts needed from your side. You just take GraalVM, replace it as your Java distribution, and you can run your applications as they are. The next one is JavaScript, and we have our own JavaScript engine that was designed with high performance and high compatibility in mind. This way we can execute JavaScript code. Another one is Ruby. We have a Truffle Ruby, which is our Ruby implementation. And for those of you who maybe are dealing with things like statistics and data science, you may be interested in R. That is also something that we support. One more language is Python, and that one is more of early stage one. So we do support Python. There already are some things that would work, and if you're a curious user, you can try our Python implementation, but it is still an ongoing project for us. And the last from the languages set is C, C++, basically any language that you can compile down to LLVM bitcode, you can also run it on GraalVM. So talking about platforms, we can run in the context of OpenJDK. Another one is Node.js, so we can also run your unmodified Node.js application. Another interesting case is database, so you can embed GraalVM in your database, and this way have access to GraalVM languages and also libraries that they provide right in your database. And the last one is a standalone mode. This is the native image that I mentioned, where you can compile the application ahead of time to a native binary, and it will be running completely standalone. Production ready. So this was a huge milestone for us, because the exact organization where I work is called Oracle Labs, and we are an R&D unit within Oracle. So we do a lot of research. We have several projects ongoing, and GraalVM is one of those. And as of May this year, it became production ready. It was our first production ready release called 19.0. And since then, we've also released 2 more versions. So currently, the most up-to-date one is 19.2.1. GraalVM comes in 2 versions. One is called Community Edition. It is open source, completely free to use. The development is happening on GitHub, and we have nice active community there working on it with us, and that is something you can take a look at it from the inside or maybe contribute if you like. And another one is Enterprise Edition, which is requiring commercial license to use, and also it is free to use for Oracle Cloud users. Talking about open source, this is the list of our open source project. You see that there are quite a few of them. So those are language implementations, core repository, which includes things like compiler, language implementation API, and so on. And also Visual VM here is representing our tools. Overall, that's more than 3.6 million lines of code that our team supports continuously. And if you are an open source contributor, or if you would like to become one, there are a couple of ways in which you can contribute. First of all, you can report an issue, and that's already really helpful for us, because we can take a look at your issue and see what's happening and improve based on that. The next one is you can also submit your PR. You can extend library support, or that is sometimes overlooked dimension of open source contribution, but docs are also important, so that's another way to contribute. And moving on to the exact features and demos and what you can do with GraalVM. So first I want to talk about Java and JVM languages, because that is Devoxx, and I imagine that most of you here are Java developers, right? So how many of you write Java code like daily? Okay, most of you. So that's the part for you, and the benefits for JVM and Java comes from our compiler. So GraalVM compiler is a brand new compiler written itself from scratch and written itself in Java. Also, it has many of the traditional compiler optimizations, but also adds a few on top of that. And you can use it to optimize your application performance or to compile the application ahead of time, because it can work in both modes, in JIT and IoT. And that is exactly a chart showing what GraalVM can do for Java applications. And I just want to emphasize here this distinction between JIT and IoT, because the IoT thing itself is so exciting that sometimes people associate GraalVM only with native images. But that's not completely true, because we can do traditional just-in-time compilation also. So with GraalVM, you can do both. For just-in-time compilation, you just do like you normally do Java and give it your application. For ahead-of-time compilation, it's slightly different. So you can think of it as of working with your application, breaking it into 2 stages. So the first stage is the build time, where you actually build your native image. And the next one is the runtime, where you actually run it. And the idea is here to move all the heavy lifting from the runtime to build time. So you do as much as possible at the image build time, so then you can start really fast and don't need as much memory at the image runtime. So talking about performance, it's hard not to mention benchmarks, and this is one of the benchmark suites that I would like to show you. It's called Renaissance Dev, and it's a bunch of Java and Scala benchmarks, and you can see here how GraalVM compiler performs comparing to C2, which is Hotspot VM default server-side compiler. So in red, this is GraalVM Enterprise Edition, and in gray, it's GraalVM Community Edition. So the numbers vary, and what we usually recommend here is that you take GraalVM and you try it on your workload, and then you can make decisions of based on how much performance it would give you for your particular workload, because it strongly depends on the type of application that you run. And I also want to mention Scala. How many of you do Scala here? Okay, a few people. And for Scala, that is the place where GraalVM compiler specifically shines, because with Scala, we can reduce a lot of object allocations, and that allows your program to run faster. So on Scala, you typically can get around 10–15% with Community Edition, and up to 30–35% speed up with Enterprise Edition. And that is perhaps one of the reasons why, for example, Twitter is using GraalVM in production. GraalVM native image. So I want to stop a bit more on this one, because that's very interesting and also requires some more explanation. So GraalVM native image is a technology that allows you to produce a standalone native executable that will no longer be dependent on the JVM. And this way it starts really fast, because you don't need to do as much work at the startup. So comparing to working in a JIT mode, when you start with native application, you already start with optimized code and pre-initialized heap, and you don't need to perform all that work on loading and verifying and optimizing your code. So you really start with already optimized code. Also, it has less memory footprint, once again, because you don't need that code infrastructure anymore. You just start with the code that is needed for your application to run. And it is, once again, ahead of time compiled with the same compiler that is doing the JIT compilation. Yeah, and I want to show you a little demo. And this one is fairly new to me. I just tried it 2 days ago, so I do hope it works. So we often get questions about GraalVM and Spring, and that is still work in progress. So if you're interested in this project, there is a page on GitHub where you can track the progress of GraalVM working with Spring. But there is already a bunch of applications that would work with GraalVM, and also in order to run those, you would need to get this I think it's called Spring Graal Native Experimental Build, and then you can run these applications. So I got it from GitHub. I built this project at home, and these are the bunch of applications that you can try running. I didn't try all of them, but this one, Webflux Native, called my attention, and I wanted to try this one, so let's see how it works. So what I have here is a pre-compiled version of this application, compiled with GraalVM native image. And if you want to try it at home, I think all of those demos have this compiled script inside, so that's fairly easy to try them. Since I already have it and I already compiled it, I can just run it as a normal application and see how it works. Yeah, so you see that it's already started. Yeah, basically it was very fast, so you can barely notice this startup time. And I can check how it is doing and what it's doing at the port 8080. So if I look into it, yeah, it says hi, which is not a lot, but you see that it's working, and it's working as a native application. Yeah, so going back to the slides. Yeah. One more interesting case that we see specifically, for example, in community is people compiling their everyday like tools and programs that you deal with daily ahead of time so they can work faster, and this is why you don't need to wait until they work. So this is an example of compiling Scala C, which is Scala compiler, and this way you see that it's giving us results faster because it's already pre-compiled. Another interesting case is this native startup time and memory consumption chart. So you see that on top here, green, this is GraalVM native, and the blue one is regular JVM. And the regular JVM, I think it's a basic like HTTP server, which is basically a response to each request with some, let's say, hello world. So this is how it behaves in native mode and in just-in-time compilation mode. So just-in-time compilation mode, it needs more than half a second to start responding, which is quite a bit for such a trivial task. When compiled as a GraalVM native image, you see that it's taken basically no time to start working. And the same goes for memory. So the memory difference here is something like, I don't know, something like 7x. So that's the memory saving that you get. And talking about microservices frameworks, so these are the bunch of microservice frameworks that support GraalVM native image. And here is, you can see the comparison of GraalVM native image, JDK12 in orange and JDK8 in red. And just the bottom line here is I encourage you to look at it not of comparing the frameworks itself, but rather comparing the JIT and IoT mode. So you see that no matter which frameworks you choose, basically you get fairly fast startup, something in between 16 milliseconds and up to 35. And the same goes for memory usage. So once again, there is some difference, but overall, IoT is so much faster no matter what framework you choose. So native image, and I'm just going briefly through it, and tomorrow we'll talk a bit more about it. So native image may require some additional configuration from your side, and there are a couple ways to do it. So for things like reflection, proxy usage, and so on, you may need to provide us a configuration file so that we can use it at build time and build the application based on that information that you give us. So you can do it manually, or you can use our tracing agent, and it will output this information for you. And a few more resources, because I'm limited in time. So if you like native image, there are a couple of resources that you can use. First of all, we have great reference manual with flags and use cases and things like that, where you can read more and see some examples. Another one is improving performance of GraalVM native image with PGO. So PGO is profile guided optimizations, and that's basically the way to optimize your application to the profile and information that you can provide us. So that is the reason why, for example, JIT mode is so good, because it can collect this profile and information over time and optimize for it. And since we compile ahead of time, this ability is not available for us. But if you give us this profiling data, we can optimize for specifically those use cases. So that's explaining the way to do it. And the last link here is our talk from Code One this year from our native image component lead, Christian Wimmer. So you can really learn more about where GraalVM native image currently is and where it is moving, some kind of roadmap for it. The next one is JavaScript and Node.js. So how many of you deal with JavaScript? Okay, quite a few, so I will stop a bit here. So, as I mentioned, we have a JavaScript engine. Let me just go back. It is compatible with ECMAScript latest standards. Also, we constantly test against 90,000 of NPM modules to make sure we are keeping this compatibility level high. And that is something you can use and also get access to the language interop that GraalVM provides for you and to the common tooling. So we also have this compatibility tool, and I just had this question during the break, like how can I make sure that, for example, that NPM module that I'm using is compatible with GraalVM. So we have a tool like this, and you can just type your module name in there and see whether it is compatible on this stage. But most likely it is, because the compatibility level for JavaScript is very high. And also with the same thing, you can also test like RubyGem and R packages, whether or not they are compatible at the with GraalVM at this stage. And Nashorn, this is one more thing where we get some questions. So there is ability to migrate if you are a Nashorn user, and we have this migration guide ready for you so that you know what way to migrate would be better. And polyglot programs. So that's another hot topic around GraalVM, and that is because we have language implementation API called Truffle, and that is the way we bring all of those languages to one platform. So you see that we support So we see that we support Java and JVM languages. That's just with this bond of Hotspot VM and GraalVM compiler, which kind of makes sense. But also we support more languages through this API. And that is the way we implemented all of them. And that's basically also the way you can implement your own language on GraalVM. So there is such possibility, and there are some companies who do this. So if you have some custom, maybe in-house language that you're dealing with, you can implement it on GraalVM and get interop and tools out of the box. Yeah, and I want to show you this Polyglot demo. So what I have here is a fairly simple case of Polyglot, just to show you, like, in general, what would be the steps you need to take. Yeah, so this is a Java program. You see that it has the main method, it prints out the line, and also we have JavaScript over here. So basically the way to implement this is to create a context and let us know that this is JavaScript, and then give us the actual code that we need to evaluate. And that is all happening at once. So if you want to try it, let me go up. Yeah, so this is my file over here. So there are a couple of ways I can go from here. So I can run it with my normal Java command, because I'm using GraalVM distribution as default, and it will work like this. So hello from Java, and the next thing comes hello from JavaScript. Or, since this is a Java application, and we already discussed that I can compile Java application ahead of time into a native binary, I can also compile this thing into a native binary with the JavaScript support. So I already did it, so we can move on faster in the presentation, but the way you would do this is just native image and just give it the class file, and it will compile it for you. So I already have it pre-compiled, and it's over here, hello polyglot binary. And if I run it as a program, you see that it's doing the same thing. Yeah, so it's working exactly the same. Hello from Java, hello from JavaScript, only it's doing it faster because it's pre-compiled. And basically, there is almost no limitation of how far you can go with these polyglot capabilities. So if you like, you can also mix and match, let's say, like we have here, Java, JavaScript, and R, and they will all work together. So I can just go here. And here I have this server.js file. And the way to run it will be like node, and I need to specify that I want to run it on a JVM, and I also want to specify that this is a polyglot application. Yeah, polyglot, and then I give it the actual file, and it will start running in a bit. Yeah, up and running, and let's check how it's doing. So it will load in a bit, because as I mentioned, there are three languages in there. So this is basically, you see JavaScript here. There is also big integer over here coming from Java, and there is R that is building this cloud plot for us. And if I take a look at this is how it's looking. So JavaScript, Java, and R. And also all the subsequent requests will be so much faster because we already initialized everything. So there is, there is a way to go really fast. And also, as I reload it, you see that it's rebuilding itself each time, so it's not that I'm showing you a PNG on something. And moving on back to these slides. Yeah. Another interesting case is in database. So for example, with GraalVM, you can use in your database, like in this example, NPM modules. So the way to do it is just to grab this module. In this case, it's validator. And I can use it in a database like this. So for example, I try on it hello.world@oracle.com, and it says to me, yeah, this looks like an email. And then when I try hello.world, it says that it's not an email. So yeah, that's the way you can use it right in your database. And also, when you are dealing with polyglot applications, you would need tools for this. And one of the tools you can use is our version of Visual VM. it has support for those that we call them guest languages. So for example, in this case, it's Ruby, and you can see this heap dump from Ruby. And another interesting case that I've seen, and this is coming from Java Zone. So my knowledge of this use case is based on this talk. I did not take part of it, but as this guy, Nathan, presented it. So that was the work they've done for the Dutch National Police. And it was interesting because you can imagine at police, they do a lot of paperwork, and they were trying to move it into a digital world so they can operate on those documents and collaborate on them online. And the way they did it is they had some old monolith application, and they broke it down into Scala microservices. And also they wanted to use R because they wanted to apply some data science approaches on this workload. And that is actually a very good use case for GraalVM because we have R implementation. It's called FastR, and we have this nice interop with Scala. So they basically implemented it like this, and that's really working well because R can provide all those data science libraries that are easy to use. And moving on into even more fantastic cases, so with GraalVM, it is possible to build applications in Java for platforms like iOS and Android. This is an ongoing project that we are working on with the Gluon team. So basically, you can just compile your application as a native binary, and it will be platform-specific for AMD64 or AR64. So I think that's still work in progress, but there are already some things that you can try with it. And moving on to more real-world use cases, I want to show you very quickly a few examples of companies who already use GraalVM. So one of them is Twitter, and I think you know this guy over here. It's Chris Tallinger, and he is giving, I think, a keynote tomorrow in the morning. So he's from Twitter, and they are using GraalVM for quite a while now. They were one of our first early adopters. And the way they use it is they have a lot of Scala microservices. And as I said, GraalVM is specifically good at optimizing Scala code. So they tested it, I think, at a tweet service, like the service that allows you to read and write tweets. And they've seen something like 10% speed up on this one, and that's even more impressive for huge scale systems like Twitter, where whatever change you are doing is then scaled by thousands of instances that you are running. And they also see latency improvements with GraalVM. They're using GraalVM Community Edition, but the benefits are enough for them to keep using it. And one more interesting thing, because sometimes we hear a question like, can I migrate to GraalVM? Is it ready to use? So they say that they've been using it for quite a while, and in the last 2.5 years, they haven't run into any issues. One more adopter, which is quite early, latest one, is Oracle Cloud Infrastructure. So it runs a lot of internal services, like for example, a telemetry service, and they migrated it from Java and to GraalVM, and they've seen these improvements in throughput and Justintime. And another one is our collaboration with Nvidia. So with this collaboration, you can now access GPU kernels from the GraalVM languages. And what's coming next, really quick here. So we have a version roadmap, because, for example, if you would like to migrate to GraalVM, I imagine you would want to know how would the releases go. So this is our release model. We have major releases each 3 months, so basically 4 releases a year. So you can prepare for those. That's publicly available page. And also we have LTS releases, which would have support for longer. And also we will have a new release, 90.3, coming in just a few weeks, and that is something you can also try. I want to go briefly through our recent updates. So we are constantly adding things, changing things, improving things. One of the recent ones is class initialization in native image. So now by default they are initialized in runtime and not at the build time, but this is something that you can configure if you would like that to be custom for your application. One more thing is that we have this little Visual Studio Code plugin. So if you tried it, please get to us with feedback. We are really curious how it is working for you. And what's coming next for GraalVM? So first of all, GTK 11 builds, and we get this question a lot. Like people ask where are GTK 11 builds, but when we ask back what version of Java are you using, almost everyone replies with Java 8. But anyway, GTK 11 builds are coming in the next release. They are scheduled to arrive in 90.3 on November 19th. Also, we are working on more platform support like ARM64 and improving our Windows support. And one more thing is new GC for native image. So that's something that we are working on right now too. More languages, more platforms, and if you see something missing, like your favorite language or your favorite library, that is something that you can contribute, and we'll be happy to accept your contribution. So just to summarize how you can use GraalVM. First of all, you can run your applications faster with a new compiler. You can start up your applications really fast and consume less resources, write polyglot apps and don't need to deal with this polyglot logic manually. And also you can embed it in your platform. A good starting point is this website, graalvm.org. That is where you can get documentation. That is where you can get community support and get the downloads, like the actual binaries. And a few more links for you. So to download GraalVM, it's graalvm.org. If you want to check on the latest updates, we are very active on Twitter, so perhaps that will be the best way. And if you need help, we have a bunch of community resources. We have this mailing list, and also we have a community Slack where you talk to other community members, and you can also talk to our team members. That's all what I had for you. That's my name, that's my Twitter handle, and also I have one more session tomorrow about performance optimizations with GraalVM. And I think you can also rate talks here, so please rate this talk. And if you like GraalVM, I have some stickers, come grab some, or if you just like stickers, that's also cool. So just come and let's talk. Thank you. Any questions, or would you rather ask privately? Yeah, go ahead. I will repeat the question, that's okay.
Thank you.
So the question is about enterprise version, how it is faster than the community version. So like globally, functionally, they are very close. So all of the features that I've talked about, all of the components are present in both versions. So in Community Edition, you can also compile ahead of time and do polyglot application. But Enterprise Edition is slightly different. So for example, the compiler has a few more optimization phases, and also there are a bit more like small features that overall contribute to this performance difference. What we usually recommend is that you take both editions, you compare performance on your workload, and if you see a significant difference between them two, so a difference that you would be willing to pay for, then you get a commercial license, because it's free for evaluation purposes. We understand that you may need to evaluate it, that you may need to work on some proof of concept, and so on. So it's free for evaluation purposes, and up until the moment where you decide to move your production to GraalVM, that's when you need a commercial license.
Hello. I saw some test cases, performance improvement is bigger. In some test cases, it's lower. For example, naive Bayes is like 3 times better than plain old JDK. What is the difference in these test cases? What features are better optimized by GraalVM? Where it makes more sense to use it?
It's a bit of echo here, so I will repeat the question just to understand that I understood it completely. So where it definitely makes sense to use GraalVM if you are looking for performance improvements, yes?
In which use cases GraalVM gives the best improvement in performance?
Mm-hmm. Yeah, so a quick note here, and I will reply to the question. So Hotspot VM and C2 itself is a state-of-art technology, so it's really hard to beat. and we understand that. And there are quite a few workloads that would see very good performance with C2 too. There are another ones, like for example, Scala. This is a space where you would definitely see improvements from moving to GraalVM. Also depending like on the type of code you write and on dependencies that you are using. So for example, if you do a lot of object allocations, that is definitely something where you would see improvement. Yeah, but overall you need to test and compare, and then you can know for sure because each workload is very different. And I can like talk to you more about this during the break if you don't mind.
Okay, thank you.
Hi, can you? Hello. You've shown that GraalVM currently has some. Can you hear me?
Barely, but yeah.
Okay.
Yeah, now
is it
better.
Okay. Do you have any plans to integrate GraalVM with LLVM more tightly? Because currently we can compile like LLVM code to Java code, but what about replacing LLVM API and support all that sets of languages which LLVM supports?
Yeah, so your question is about LLVM support in GraalVM, yeah?
Yeah, will it be more tight in the future? Because currently it's quite poor.
Yeah, I did not mention it because this talk is more like Java oriented, but I think you already tried GraalVM and you must know that we have LLVM runtime, yeah, which is called Sulon. And also, I think recently in 19.2, we introduced what is called LLVM toolchain, like a better way for you to build LLVM project on GraalVM. I think in 19.2 it was an experimental feature, but we plan to extend support for it. I cannot tell more right now, I think, but we are planning to extend the support, like to make it default or experimental, and I can also show you during the breaks, like what exactly I'm talking about.
Is it public, available on GitHub? Can we play with that? I mean, is it public?
Yeah, it is a public thing. I think we even described it in our list notes for 19.2.
Thank you.
You're welcome. Okay, let's take it to the breaks, and please let's talk and grab some stickers. Thank you.